Hello, this is our presentation on MATLAB, the Material Efficiency Laboratory in Austria. My name is Johannes Fresner. My colleague is Christina Krenn. We are both from Stenum, and Andreas van Hametner is representing the Ressourcenforum Austria. The project was initiated in 2019 by the Austrian Ministry of Climate, Environment, Technology and Innovation. The idea was to create a strategy to reach out to the large number of enterprises in Austria with resource efficiency. We have about 900,000 medium, small, micro enterprises in Austria. Resource efficiency includes, in this context, all raw materials, all auxiliary materials, as well as energy and water the company might be using in generating their products and services. The activities within this program were the acquisition of about 10 pilot companies, the development of a resource efficiency tool, using a certain technique for formulating questions, which we call the lines of evolutions, 10 initial assessments in companies of different sectors, the generation of a joint learning and problem-solving environment consisting of common workshops, meeting with experts, and accompanied by communication activities. The tool consisted of two major parts, one consisting of worksheets, worksheet on collecting data on input and outputs of a company, lifecycle analysis, stakeholder analysis, and a list of process units. The core part of the tools are 47 questions, which were formulated as lines of evolutions of organization or technology, supported by additional analysis like material flow analysis, energy analysis, root source analysis, leading to the identification of options to increase the resource efficiency of the participating companies. A line of evolution is shown here in this example for cutting in metal manufacturing. A line of evolution shows the different steps a technology might develop through and related to the resource efficiency of the individual steps. Like metal cutting starts manual, scrap is probably more than 20%. The material which is off-cut is recycled. Second stage, already improved, would be manual management of cut-offs. They are returned to stock and selected with priority when new material is needed. Third stage, again an advancement, would be computer assisted pattern optimization, working from coils where applicable, thus generating waste of less than 5%. And the ideal best practice at the moment is fully automatized, optimized design, considering the raw material or additive manufacturing, especially of small lots. A company now would allocate the practices they use on this line of evolution, and clearly the next steps would indicate potential for improvement and hopefully generate ideas what the company in practical terms can do to enhance their resource efficiency. This analysis is supported by showing material flows in Sankey diagrams, also clearly indicating where and how much waste is generated, and fishbone diagrams to analyze the root causes of waste and help in identifying options for improvement. This spider diagram shows the result of the evaluation of the questions, which is the overall potential of the respective case study company in terms of strategy, management system, processes, sector-specific processes, and product lifecycle. For all these individual subsectors, similar charts would be plotted so that the company knows where are there opportunities to improve their resource efficiency and what could be the priorities. And from the lines of evolution of technological and organizational aspects, options can be generated. All in all, 87 options were generated in the 10 participating companies. About 40% were related to energy, about 60% were related to using raw materials better, substituting raw materials, improving the useful life of auxiliary materials like hydraulic fluids, like lubricants, like solvents, or reusing byproducts in other companies by recycling. These are some examples out of the 87 suggestions relating, for example, to the replacement of chemicals, to improve the useful life of surface treatment solutions and reduce problems with the wastewater, reduction of packaging in the supply chain, as well as when delivering to clients. In one company, there is a potential to recycle 50% of plastic waste by collecting it separately, clearly labeling it, and reusing it when similar material is in demand. Another company, paint consumption could be reduced by 10% by improving cleaning practices. In an injection molding company's machines could be optimized. The parameters temperature, pressure, time were modified in a way that 15% electricity could be saved. Regional sourcing applies, amongst others, to wood processing companies. In one company, they are replacing timber which they are buying from Asia by regionally grown timber. Here we see the ratio of byproducts to overall material input for the sectors which were participating in metal processing. We find 5 to 7% non-productive output, whereas in wood processing we found 60 to 70%. About 10% of these could be reduced, optimizing existing product services, the organization, or processes. We had a strong communication part of the project. We hosted 4 workshops where the companies participated together with peers. We circulated 4 newsletters with relevant technological information. We were present on Facebook and LinkedIn to spread the word of mouth in the project. We cooperated with sector organizations and regional organizations to involve their members. The lessons learned are we definitely have to address senior management, maybe by involving regional associations, clubs, clusters. The personal meeting with managing directors was much more effective than sending out emails or distributing folders or brochures. Savings were important motivations for the CEOs to participate, but as were strategic aspects like changes in legislation or bending constraints in using raw materials or behavior of stakeholders towards the company. One important finding is that we definitely have to pre-process collected technical knowledge into concrete suggestions to act like a funnel to provide tailored advice considering the actual situation of the company, its products, services, and processes. In this process, Sankey diagrams and fishbone diagrams are really useful to provide structure to the procedure, to visualize material and waste flows, to show priorities, and to document achievements when options were implemented. To provide for a lasting network, the series of workshops will be continued in different regions of Austria. To summarize, I want to use a quotation by Henry Ford. Coming together is a beginning, staying together is progress, working together is success. So I would consider the program as a success, as it brought together a number of enterprises with their regional associations and clusters in working on resource efficiency, actually implementing quite a few opportunities and spreading the word of mouth to their colleagues. If there are further questions, we would be glad to answer. Please contact us at stenum.at or using the email addresses which you see in this slide. Thank you very much for your attention.